Welcome to the next lecture. In previous lecture we have seen per unit analysis of single phase system and also per unit analysis of single phase transformers. From per unit analysis of single phase transformers we have clearly concluded that the per unit current in primary and per unit current in the secondary of a transformer are same. That means I1 per unit equal to I2 per unit, V1 per unit equal to V2 per unit, and Z01 per unit equal to Z02 per unit. Now in this lecture we will see the per unit analysis of three phase system. It might be a single phase system or three phase system. Fundamentally we have a four variables. That means we need to assign the base quantities for these four variables. Now what are the four variables? We already discussed in single phase system. The four variables are three phase apparent power base, that means simply S base. Now voltage base, current base and impedance base. But careful, in single phase system there is no concept of line voltage. Whatever the voltage we are saying, that is by default phase voltage. Similarly, there is no concept of line current. Whatever the current we are saying, that is by default phase current. But when it comes to three phase system, if it is a voltage means the question will come whether it is a line voltage or phase voltage. Similarly, if it is a current means again the question will come whether it is a line current or phase current. So that's why, so there exists a line voltage base here. Voltage base means there exists a line voltage base and separately there exists phase voltage base. And similarly, when you are saying the line current now, there exists, when you are saying base current now, there exists a line current base and there exists a phase current base. So you should be very careful with the line and phase quantities. But strictly speaking, there is no much difficulty here to calculate the line voltage and phase voltage, because if it is a star connection, the line voltage equal to root 3 times the phase voltage. I am talking about the magnitudes. If it is a delta connection, line voltage equal to phase voltage. Simple fundamental. And if it is a star connection, line current equal to phase current. If it is a delta connection, line current equal to root 3 times the phase current. Nothing else. Now we will see what is the relation between S, V, I and Z. Sir, it might be a star connection or it might be a delta connection. These relations are valid. Okay. So I can write S base equal to root 3 times VL base, that means line voltage base multiplied with line current base. You can also write S base equal to 3 times phase voltage base and what? Multiplied with phase current base. But careful here, VI, they are just magnitudes, no phase angles, because we defined clearly the base quantities having only magnitude, they don't have any phase angles. That means S, VL, IL, V phase and I phase are having only magnitudes. Now next one, impedance base. Tell me what is impedance base? V base by I base. Okay, in a single phase system directly we are written V base by I base, but in a three phase system V means there exists a line voltage and phase voltage, I means there exists a line current and phase current. So what is the correct relation? Sir, very simple thing here. The common sense is that the impedance is always a per phase quantity. There is no concept of line impedance, okay, and there is no concept of phase impedance. Simply it is a per phase quantity. So that means the impedance is always a per phase quantity. That's why I need to write V phase base by I phase base. Sir, if you write Z base equal to V line base by I line base, that is blunder. Careful, many people will commit a mistake here. Z base is always V phase base by I phase base. Clear? Now, let's see, we have 6 variables indirectly. Why? Because we have S base, V line base, V phase base, I line base, I phase base and what? Z base. Okay, but what are the known base? What are the known base here? To understand that, I will take an example of a synchronous machine and its rating. Let's see, if you have a synchronous generator, on the nameplate of the synchronous generator, 2 ratings will be definitely given. For example, it is a 11 kV 100 MVA synchronous machine. It is 11 kV 100 MVA synchronous machine. Now tell me, voltage rating and MVA rating is available. Voltage rating and MVA rating is available. Tell me, if the voltage rating is available, I can define the base voltage. If MVA rating is available, I can define the base MVA, that means S base. But tell me whether it is phase voltage or line voltage. Sir, by default on the name plates of any electrical machine or any electrical equipment you see, definitely line voltage is given, not phase voltage. And MVA rating means it is always 3-phase MVA rating but not per phase MVA rating. Careful sir, in a 3-phase element, it might be a generator, it might be a transformer, it might be a transmission line. On the name plate, line voltage rating and what? 3-phase apparent power ratings are given. So that's why what I can write here is, this is line voltage base and this is what? 3-phase apparent power base, by default S base. Okay, so that's why what are the known variables here? Known base. What is the known base? We know line voltage base and 3-phase apparent power base, simply S base. Tell me what is unknown base? The unknown base is V phase base, I line base, I phase base and Z base. Now we need to define V phase base, I line base, I phase base and Z base. Careful, in terms of what? Known parameters. In terms of these known parameters, that means in terms of line voltage base and S base, we need to define V phase base, I line base, I phase base and Z base. Clear? So, but V phase base, I line base and I phase base and Z base are really going to change based on the star connection and delta connection. Clear? But till here the things are common for star connection and delta connection. Okay? Clear? It might be a star connection or delta connection. Up to here all the things are valid. Now onwards we need to define separately for star connection and delta connection. Okay, first let me define for star connection. Suppose if it is a star connected system. Sir, we know the fundamental. In case of star connection, the actual line voltage, I am not talking about the base quantities, actual things I will talk about. First, the actual line voltage, it is a phasor. Line voltage phasor is √3 times the phase voltage phasor and at an angle plus 30 degrees. What you can understand here? The magnitude of the line voltage is √3 times the magnitude of the phase voltage. Okay, but line voltage leads the phase voltage by 30 degrees. That's what the meaning of this. We know this fundamental already. So, what is line current? That is equal to phase current. See, these two relations are valid for star connection. Clear? But careful, now we are talking about what? Base quantities. When you are talking about the base quantities, you don't need to worry about the phase angle. That means, if I want magnitude, how to define magnitude? Line voltage magnitude equal to √3 times the phase voltage magnitude. That's it. Line current magnitude equal to phase current magnitude. Clear? So, what is V phase base? V phase base equal to what? V line base by √3. Is minus 30 degrees will come here. For example, actual parameters, how to say V phase equal to V line by √3 at an angle minus 30. But is it minus 30 will come here? No, because base quantities means, again I am saying, they are only magnitudes. Okay, V phase base equal to V line base by √3. Okay, so we have written V phase base, that is unknown base, in terms of known base. Okay, then what is I phase base? That is equal to what? I line base. Now what is that I line base? See from here sir, have a look. I line base equal to S base by √3 times the V line base. So because this formula valid for star connection as well as delta connection. That's why I am writing I line base equal to S base by √3 times the V line base. So S base by √3 times V line base. Clear? So that's about I phase base. And I phase base and I line base, we are written in terms of known. What is known? S base is known and line voltage base is known. Now, next important thing is Z base. What is Z base? We know that V phase base by what? I phase base. Clear? But for star connection, what is V phase base? V line base by root 3. Okay, I will write that V line base by root 3. What about I phase base? Equal to I line base. Now tell me, what is I line base? S base by root 3 times V line base. S base by root 3 times V line base. So let me substitute that. V line base by root 3 divided with I line base is what? S base by root 3 times V line base. Root 3 get cancelled. V line base will be coming to the numerator, and finally Z base for star connection is V line base square divided with S base. Now this is for star connection. So we defined the remaining 4 variable in terms of known variables. V phase base is V line base by root 3. I phase base, I line base equal to what? S base by root 3 times V line base, and Z base is V line base square by S base. Now we will see what is the relation between per unit line voltage and per unit phase voltage, and per unit line current and per unit phase current. Sir, we know that in case of star connection, the actual line voltage, actual, A indicates actual here, actual line voltage equal to what? Root 3 times the actual phase voltage at an angle plus 30 degrees. Clear? Now, what is the line voltage per unit? The line voltage per unit equal to line voltage actual divided with what? Line voltage base. Line voltage per unit equal to line voltage actual divided with line voltage base. Okay. Now, similarly, what is phase voltage in per unit? The phase voltage in per unit equal to phase voltage actual phase voltage divided with what? V phase base. Clear? Okay. Now what is the relationship between V line and what? V phase in per unit form. Okay, that's what we are going to find out here. But let's see. We know that V phase per unit equal to what? V actual phase. V actual phase is what? V actual phase is what? V actual line by root 3 at an angle minus 30. So V actual line by root 3 at an angle minus 30 degrees. Now, what about V phase base? V phase base is nothing but what? V line base by root 3. So, V line base by what? Root 3. Root 3 get cancelled. What I get now? V actual line voltage at an angle minus 30 degrees divided with what? V line base. Now tell me, what is V actual line voltage by V line base? V line per unit. So what I can write here? V phase per unit equal to what? V line per unit at an angle minus 30 degrees. V phase per unit equal to V line per unit at an angle minus 30 degrees. So from this, what we can understand is, in case of star connection, the magnitude of the phase voltage and magnitude of the line voltage in per unit form are same, but phase voltage lags the line voltage by 30 degrees, otherwise line voltage leads the phase voltage by 30 degrees. Now what is the relationship between I line per unit? I can write I phase per unit. Okay, clear? So I line per unit equal to I phase per unit. Now finally, what are the conclusions we drawn from star connection? Sir, in case of star connection, the first conclusion is V phase base equal to V line base by root 3. I phase base and I line base are what? Same, which is equal to S base by root 3 times the V line base, And what is Z base? The third conclusion. The Z base equal to V line base whole square by S base. Okay, that is the third conclusion. And fourth conclusion is the line voltage per unit equal to what? Just now we defined phase voltage per unit, but the line voltage leads the phase voltage by 30 degrees. Clear, sir? Sir, this is I written V phase equal to V line at an angle minus 30. But here what? V line equal to V phase at an angle what? Plus 30. Otherwise you can write like this. V phase per unit equal to V line per unit at an angle minus 30 degrees. Otherwise you can also define like this. The magnitude of V phase per unit equal to magnitude of V line per unit. Sir, this is very important, sir. Okay, suppose a question is given like this. In case of a star connected load, the line voltage is recorded as, in case of star connected load, the line voltage is recorded as 1 at an angle plus 30 degrees in per unit. 1 at an angle plus 30 degrees in per unit. What is the phase voltage in per unit? The phase voltage in per unit, what the people will do? Simply, they will apply the actual relations. What is the actual relation? Line voltage and phase voltage. Actual relation is what? Phase voltage is what? Line voltage by root 3. That means 1 by root 3. And phase voltage lags the line voltage by 30 degrees. That means what? Lagging means minus 30 will come. So minus 30 plus 30 is 0. Okay. But 1 by root 3 they will write. But is this correct? No. It is blunder, sir. Why? Because we are talking in per unit form. You should be very careful. In per unit form, phase voltage magnitude, line voltage magnitudes are what? Same. Just now we define magnitude of the phase voltage equal to magnitude of the line voltage. And the phase voltage lags the line voltage by 30 degrees. Okay. So actually line voltage is 1 at an angle plus 30. Now at an angle minus 30. Now simply I can write minus 30. So what I get now? 1 at an angle 0 degrees. If line voltage is 1 at an angle plus 30 degrees per unit and phase voltage is 1 at an angle 0 degrees per unit. Okay. Simple question, but more than 80% of the people will give wrong answer for this question. So you should be very careful, sir. So line voltage in per unit, phase voltage in per unit, the magnitudes are always same. Okay, there exists a phase angle just like what? Actual voltages. Okay, clear? Now, last conclusion what we have seen for star connection, the line current in per unit equal to what? Phase current in per unit. Okay, sir, these things are very important for star connection. Now we will see for delta connection. That means for delta connection also we need to define V phase base, I line base, I phase base and Z base in terms of what? Known base, that is V line base and S base. But for delta connection we know that V phase equal to what? V line. But what about I phase equal to I line by root 3 at an angle plus 30 degrees. Otherwise, what is I line equal to root 3 into I phase at an angle minus 30 degrees. That means the line voltage actual and phase voltage actual are same, but the phase current actual is line current actual by root 3 at an angle what? Plus 30 degrees. Similarly, line current equal to root 3 times the phase current at an angle minus 30 degrees. So what you can understand here, the magnitude of the phase current is magnitude of the line current by root 3 and phase current leads the line current by 30 degrees. This fundamentals we already discussed in our PS1 course. So magnitude of the line current is root 3 times the magnitude of the phase current and line current lags the phase current by 30 degrees. Clear? Now we will define what is V phase base and I phase base and I line base. Okay. Now coming to the first formula, V phase base is equal to what? V line base. Clear? Because the magnitude of phase voltage and magnitude of the line voltages are same. Clear? But what is I line base? See, I line base I can write from this S base by root 3 times V line base. Correct or not? I line base is what? S base by root 3 times V line base. But what about I phase base? I phase base is I line base by root 3. Clear? Now, what is I line base? S base by root 3 times the V line base. You just divide this with again root 3. So, what I get now? Simply S base by 3 times V line base. That's about I phase base. Clear? S base by 3 times the V line base. Otherwise, from here, what is I phase base? Actually, this is base. What is I phase base? S base by 3 times the V phase base. V phase base equal to V line base. Both the way you get what? Same answer. Now, coming to Z base. What is Z base, sir? Always V phase base by what? I phase base. But what we know? V line base we know. And what? S base we know. That's why we need to write Z base in terms of V line base and S base. Okay. Now tell me, what is V phase base and V line base? Same. And what is I phase base? S base by 3 times V line base. Now finally, the Z base equal to what I get now? Z base equal to 3 times V line base whole square by what? S base. Clear? That's about the Z base. So we defined what is V phase base, what is I line base, what is I phase base, and what is Z base. Now we will see the per unit line voltage relation with per unit phase voltage for delta connection. Sir, the actual line voltage is equal to what? Actual phase voltage. But what about actual line current? Equal to what? Root 3 times actual phase current at an angle minus 30 degrees. Clear? So, using these relations, we need to calculate what is the per unit line current and per unit phase current relation, per unit line voltage and per unit phase voltage relation. But anyway, actual line voltage and actual phase voltages are same. In per unit also they are same. I don't need to prove that. Okay. So, what I can write now? V line per unit for delta equal to what? V phase per unit. V line per unit equal to V phase per unit. Okay. But what about the current relations? Sir, we know that I line per unit equal to what? I actual line current by I line base. I actual line by I line base. Now, what about I phase per unit? I actual phase voltage, phase current divided with I phase current base. Clear? These are phasors, right? So, what I can write here is I phase per unit equal to I actual phase. I actual phase, what I can write? I actual line by root 3. I actual line by root 3 at an angle plus 30. Okay? Clear? Otherwise you see here. I phase equal to what? I line by root 3 at an angle plus 30 degrees. So, I actual line current by root 3 at an angle plus 30 degrees divided with. What is I phase base? I phase base equal to I line base by root 3. So, I line base by root 3. So, root 3 get cancelled. What I get now? I phase per unit equal to, I phase per unit equal to what? Root 3 get cancelled. I actual line current by I line current base. So, what I get now? The line current in per unit at an angle plus 30 degrees. So, What we can understand here, sir? Again, the phase current in per unit form equal to line current in per unit form, but at an angle plus 30 degrees. Magnitude of the phase current in per unit equal to magnitude of the line current in per unit. So, the phase current per unit magnitude equal to line current per unit magnitude. Okay, clear? Otherwise, we can write line current in per unit equal to what? Phase current in per unit, but at an angle minus 30 degrees. Clear? So, finally, the point is, it might be a star connection, it might be a delta connection, that root 3 factor will not be there. But in case of actual, yes, that root 3 factor will be there. Now we will summarize the points here. So, what is known, sir? V line base and S base is known. It might be a star connection or what? Delta connection. Clear? V line base and S base is known. Now, what about V phase base? V line base by root 3. What about here? V phase base is nothing but V line base. V phase base equal to V line base. Now, what about I phase base here? I phase base equal to I line base equal to S base by root 3 times V line base. I phase base equal to I line base equal to S base by root 3 times the V line base. But what about here? I phase base is S base by root 3 times, 3 times V line base, and I line base is what? S base by root 3 times V line base. Okay, we know that the line voltage in per unit here equal to phase voltage per unit at an angle plus 30 degrees. Clear? But here line voltage per unit equal to phase voltage per unit. And what is the phase voltage per unit? That is line voltage per unit, but at an angle minus 30 degrees. Per unit form I am writing. So, what about here now? The line current equal to line current in per unit form equal to phase current in per unit form at an angle minus 30 degrees. But phase current in per unit equal to line current in per unit at an angle plus 30 degrees. Okay, but here the line current in per unit, phase current in per unit are always same. Clear? Now these relations are very important, sir. Okay, so we define phase voltage base, phase current base, line current base, and then we have written relation between line and phase quantities in per unit form for voltages and currents. Now we will go through this example. 11 kV 100 MVA 3-phase transmission line has series impedance of 1.21 plus J 3.63 ohms. Calculate what is S base, apparent power base, line voltage base, phase voltage base, line current base, phase current base, and also we need to calculate Z base, and then we need to calculate R per unit and X per unit. But what is R actual and X actual? It's clearly given. The series impedance means the resistance is given and reactance also what given here. So we need to calculate first what is S base. We already discussed the default base, it might be a single phase system or three phase system. The default base is what? The rating of the machine. Let's see, the 100 MVA 11 kV transmission line. So that's why, so what I can write here is S base is 100 MVA. S base is 100 MVA. And now tell me, what is line voltage base? That is 11 kV. So 100 MVA by 11 kV. So tell me, what is V phase base? But sir, it is a transmission line. Tell me, is it a star connection system or delta connection system? We already discussed in PS1. A transmission line is neither connected in star nor connected in delta. But for analysis point of view, we apply star connection principles. So that's why, what is V phase base? V phase base is V line base by root 3. That means 11 kV by root 3, which is 6.35 kV approximately. 6.35 kV. Next, what is line current base? For that we know that S base equal to root 3 times V line base into what? I line base. So from that, the line current base is S base by root 3 times V line base. So S base means 100 into 10 power 6. So divide with root 3 times 11 into 10 power 3. Since it is kV, it is MVA. So what I get now? 100 into 10 power 6 by root 3 into 11 into 10 power 3. So if I solve this, I get 5.24 kilo ampere. That is I line base. What is I phase base? Since a transmission line is treated as star connection system, I phase base equal to I line base, that is what? 5.24 kilo ampere. Now what is Z base? Simply V line base whole square by S base. Suppose if you are substituting this is in kV, na, you should substitute this in MVA. So that's why nothing wrong to write like this, kV base by what? MVA base. Clear? So K square and M get cancelled. So simply V square by VA we get. Okay. So KVB square by MVAB. That means directly you substitute what? KVB value here. What is the KVB value? 11 square. It's a line voltage, sir. By default, this is the line to line value. What about this? 3 phase value. Okay. So KVB square, K square, and here M get cancelled. That's what I am saying. So 11 square divided with what? 100 MVA directly. Okay. Otherwise you write like this, 11 into 10 power 3 whole square. Denominator 100 into 10 power 3, sorry 10 power 6. 10 power 3 whole square and 10 power 6 get cancelled. Finally what you get? 11 square by 100 only we get, both the way. So directly I am writing, that's fine. 1.21 ohms. That's what? Z base. Now after that we need to calculate what is R per unit and X per unit. Sir, in second question is asking to calculate R per unit and X per unit. So what is the R value in per unit form? R actual by Z base. Correct or not? So what is R actual? 1.21 ohms. 1.21 divided with 1.21, which is 1 per unit. Now we need to calculate what is X per unit. X per unit means X actual. 3.63 divided with 1.21 is what? Z base. X actual by Z base I have directly written. So which is what? 3 per unit. So that means what is the series impedance in per unit form? Z per unit equal to 1 plus J3. Clear? 1 plus J3 per unit is the per unit impedance of or per unit series impedance of transmission line. Now coming to next example, the per unit per phase impedance of star connected load is X per unit. The per unit per phase impedance of equivalent delta connected load is dash per unit. That means it's a star delta conversion, sir. For example, if this is 1 ohms, 1 ohms, 1 ohm and 1 ohm, then what is this values? 3 ohms. Correct or not? See, if this is R means this become what? 3 times the R in case of delta. Clear? But what I am asking is not the actual value relation, per unit value relation. That means if this is 1 per unit, what I can say here, is this 3 per unit? Is this 3 per unit here? No. This is also 1 per unit. That is what we are going to prove. Okay. So how to prove this? Let's have a look. Is clearly mentioned. This is what? X per unit. Okay. Clear? So the per unit impedance here is what? X per unit. So tell me, what is the actual impedance of star connected load here? The actual impedance of star connected load. Have a look here. I can write like this. See, Z star per unit is equal to what? X. What is Z star actual? That is Z star per unit multiplied with what? Z base. So what is Z base? Let's say this is X, Z star per unit. Z base is line voltage base square by what? S base. Since it is a star connection, simply VLB square by S base. Clear? So that is what? Z star. Okay. Now if you convert star to delta, what is the units of this, by the way? Ohms. If you convert star to delta, what is Z delta? 3 times the Z star. 3 times the Z star. So 3 times the Z star. Okay. So what is the Z star value? 3 into X into, okay, VLB square by what? S base. Okay. Clear? Now I require Z delta in per unit. What is Z delta in per unit? Z delta actual divided with what? Z base. Z base for what? Delta connection. Z base for what? Delta connection. Okay. Clear? But here Z base for what? Star connection. Z base for star and Z base for delta, not the same. Okay. Anyway, what is Z base delta? Z base for delta connection, we know clearly, sir. 3 into V line voltage base, that means line voltage base square divided with S base. Okay. Now tell me, what is Z delta per unit? So 3 into X into, that means actual value I am writing, 3 into X into VLB square by what? S base. That divided with 3 into VLB square by S base. 3 get cancelled, this get cancelled. Finally, what do you get? X per unit. So finally, the conclusion is, sir, Z star per unit equal to what? Z delta per unit. That is equal to what? X. So if we convert star to delta, the per unit impedances will not change. But if you convert star to delta, the actual impedances will change. Sir, the actual impedance, for example, here X ohms and X ohms. But what about the actual impedance of delta connection here? 3 times the X. But the per unit impedance here is X per unit, means what is the per unit impedance here? Same, X per unit. So this is very important conclusion. Please remember this. So Z star per unit equal to what? Z delta per unit. Now we will see per unit analysis of a 3-phase transformer. Sir, if it is a 3-phase transformer, then the first important thing is transformation ratio. But if the rating is given, what rating is given? The line voltage rating in the primary and what? The line voltage rating in the secondary, and S is nothing but what? 3-phase apparent power. This is given for us. Okay. By default, what is the rating here? Suppose if it is a 11 kV by 132 kV transformer. I am saying it's a 3-phase transformer, means by default this 11 kV is what? Line voltage. By default this 132 kV is what? Line voltage. But what is the phase voltage? Yeah, that depends on what is the connection. Suppose if it is a star-star transformer, then if this is 11 kV, this is 132 kV. What is the phase voltage in the primary? 11 kV by root 3. What is the phase voltage in the secondary? 132 kV by root 3. You should be very careful. Suppose if it is a star-delta connection, then what? Phase voltage in the secondary is 132 kV, because line voltage equal to what? Phase voltage. Okay, clear? But what is the transformation ratio? The transformation ratio K is defined as V2 phase by what? V1 phase. At the same time, I1 phase by what? I2 phase. You may also say I1 by I2. But careful, sorry, you can also say N2 by N1. But careful, sir, here the same relation is valid with respect to what? Base quantities also. K equal to what? V2 phase base by what? V1 phase base. Now I1 phase base by what? I2 phase base. Clear, sir? So this is the first important thing we need to notice about a three-phase transformer. For better understanding of a three-phase transformer per unit system, I will consider a star delta transformer. Okay, for example, if it is a star delta transformer, so it is a star delta transformer with a transformation ratio K. So I am going to write the primary phase quantities here, secondary phase quantities here, secondary line quantities, and here I will write primary line quantities. For example, the voltage, first I will deal with the voltage, sir. If the voltage in the primary is V1L, that is what? 1 at an angle 0 degrees volts, actual, sir. Okay, 1 at an angle 0 degrees volts. What about the phase voltage? Sir, we know that for a star connection, what is the phase voltage? Phase voltage equal to line voltage by root 3 at an angle minus 30 degrees. This is the actual relation. But per unit relation, we know this. V phase per unit equal to V line per unit. V line per unit at an angle what? Minus 30 degrees. Okay? Clear? The same relations I am going to use here. Actual voltage is what? 1 at an angle 0 degrees. Actual phase voltage, V1 phase. V1 phase. 1 by root 3 at an angle minus 30 degrees. Okay? Clear? But what is the transformation ratio K with respect to the voltages? V2 phase by V1 phase. Now tell me, if I want to calculate V2 phase, what is V1 phase? 1 by root 3 at an angle minus 30, that will be multiplied with K. So directly I am writing, sir, here. So V2 phase equal to K by root 3 at an angle minus 30 degrees volts. Clear, sir? This is also in volts. Now what about the line voltage? For a delta connection, line voltage equal to phase voltage. That's why what I can write here. So V2 line. Okay. So K by root 3 at an angle minus 30 degrees volts. Fine. That's about the actual voltages. If I am assuming the line voltage in the primary is what? 1 at an angle 0 degrees. Finally, what is the line voltage in the secondary? K by root 3 at an angle minus 30 degrees. Okay. Now tell me, what is the phase voltage here? 1 by root 3 at an angle minus 30. What is the phase voltage here? K by root 3 at an angle minus 30 degrees. Okay, fine. Now I am assuming the line voltage base, the V1L base equal to, I am assuming 1 volt. So line voltage base in the primary I am assuming 1 volt. Now if that is the case, tell me what is the line voltage in per unit? V1L. Base voltage is 1. Actual voltage is 1. So 1 divided with 1, how much it is? 1 at an angle 0 degrees per unit. Clear? Now tell me, if this is the base voltage, line voltage base, tell me what is the phase voltage base for star connection? Primary is star, careful. For star connection, phase voltage base equal to line voltage base by root 3. At an angle minus 30 will come? No. Phase angle will not come for what? Base quantities, because by default base quantities represents only magnitude. So that's why line voltage base 1 volt means, what about the phase voltage base on the primary? V1 phase base. Shall I write 1 by root 3 volts? Yes. Now tell me, 1 by root 3 at an angle minus 30 divide with what? 1 by root 3. So that's why, what is V1 phase? That is 1 by root 3 by 1 by root 3. So 1 at an angle minus 30 degrees per unit. If you have any doubt, check, sir. V phase per unit equal to V line per unit at an angle minus 30. What is V line per unit? 1 at an angle 0. What is V phase per unit? 1 at an angle minus 30. Satisfied or not? Yes. Okay. Clear? So we already proved this. Once again we proved. Okay. Anyway, so now tell me, what is the per unit voltage on this side? So we will calculate that, but before that, tell me phase voltage base is 1 by root 3. What is the phase voltage base here? V2 phase base. V2 phase base. Sir, just now we discussed V2 phase by V1 phase, V2 phase voltage base by V1 phase voltage base equal to what? K. That means V2 phase base by V1 phase base equal to K. So that's why what I can write now, if this is 1 by root 3 and then multiply with K, that will be K by root 3. K by root 3 volts. Tell me, what is V2 phase per unit? So V2 phase per unit means V2 phase actual by V2 phase base. What is V2 phase actual? K by root 3 at an angle minus 30. Divide with K by root 3. So that means what? Again I will get 1 at an angle minus 30 degrees. This is in per unit. Careful sir. That means the per unit primary voltage, per unit secondary voltages are what? Always same. Just like a single phase transformer. For a single phase transformer, per unit primary voltage equal to per unit secondary voltage. For a 3-phase transformer also that is true. But careful, only what? Phase voltage. Single phase, by default phase. 3-phase, we have a line and phase. But phase only I can say 100% they are same. But line now we are going to check. Anyway sir, what is the line voltage base here? V2 line voltage base equal to what? V2 phase voltage base. Why? What is the connection? Delta. Okay. So what I get now here? K by root 3 volts. Now tell me, what is V2L in per unit? V2L in per unit is what? V2L actual by V2L base. Tell me, K by root 3 at an angle minus 30 divided with K by root 3. So 1 at an angle minus 30 degrees. Sir, what we can conclude from here is, just check, line voltage relations. The magnitude of the line voltage in per unit form, the magnitude of the line voltage in per unit form are same. That means the magnitude of the line voltage in per unit form in the primary equal to what? Magnitude of the line voltage in per unit form in the secondary. But what about their phase angle? That is minus 30. But shall I say that always minus 30? No, that depends on connection. Okay, connection will define this. Okay, sir, if there is a phase shift between primary to secondary, actual minus 30 degrees, per unit also minus 30 degrees. That means whatever the analysis you done in 3-phase transformer, actual form, that is same for what? Per unit form with respect to phase angle, but magnitude same. Okay, that means the line voltage in the primary equal to what? Line voltage in the secondary. But careful, only magnitude, but there is a phase shift depends on connection. Star delta minus 30, delta star plus 30, star star no phase shift, delta delta no phase shift. You have studied this in 3-phase transformers. Similarly here also. Now we will see current relations. For example, if the line current here is, I1L here is 1 at an angle 0 degrees ampere. What about the phase current? I1 phase, same, 1 at an angle 0 degrees only, amperes. Why? For a star connection, line current and phase currents are same. Okay, but what about here? The phase current here is I2 phase equal to what? By K. Okay, I2 by I1 equal to 1 by K. Correct or not? So I2 is equal to 1 by K at an angle 0 degrees. Clear? But what about I2L line current here? The line current is what? Lags the phase current by 30 degrees. For a delta connection, the line current lags the phase current by what? 30 degrees. But the magnitude point of view, line current will be what? Root 3 times the phase current. Okay, that's why what I get now here, root 3 by K at an angle minus 30 degrees. There is a phase shift of what now? Minus 30 degrees from primary line current to secondary line current. Star delta transformers. That means voltage phase shift actual minus 30. Current phase shift actual, I am talking about line quantities, minus 30. Phase quantities, there is no phase shift. Clear? Now quickly I am going to select the base quantities here. For example, I1 line base equal to, let's say, 1 ampere. 1 ampere. Tell me, what about I1 phase base? I1 phase base 1 ampere only, because star connection, right? Tell me if that is the case. What is I2 phase base? 1 by K. Clear? Because I2 phase by I1 phase equal to what? 1 by K. Clear, sir? So the same thing we got 1 by K ampere. Now tell me, what is I2 line base? I2 line base is what now? So line value equal to root 3 times the phase value. That's why what I can get root 3 by K. Clear? Now tell me, so what is the per unit value here? I1L per unit. I1L per unit is what? 1 by 1. So 1 at an angle what? 0 degrees. Tell me what is I1 phase per unit? 1 by 1. 1 at an angle what? 0 degrees. Per unit only. Okay. If that is the case, tell me 1 by K by 1 by K. So again I2 phase per unit 1 at an angle 0 degrees. Tell me what about I2 line per unit? I2 line per unit is root 3 by K by root 3 by K. So 1 at an angle, but phase angle is what here? Minus 30 degrees. So from this, what you can understand, sir? Again, the per unit value of phase current in the primary, the per unit value of phase current in the secondary are same. The per unit value of phase voltage in the primary, the per unit value of phase voltage in the secondary are always same. But when you are talking about line voltage in per unit in the primary and secondary, magnitudes are same, but there exists what? Phase shift here. Okay, magnitudes are same. Check 1 at an angle 0, but here 1 at an angle minus 30. There exists a phase shift. Phase shift is because of what? Connection. Transformer action will never introduce the phase shift. Connection will introduce the phase shift. Careful about this. Clear? So I am going to write the conclusions now. Coming to the conclusions, irrespective of transformer connection, means it might be star star, star delta, delta star or delta delta. What I can write is V1 phase in per unit equal to what? V2 phase in per unit. Clear? And I1 phase per unit equal to what? I2 phase in per unit. That means the phase current in the primary and phase current in the secondary in per unit form are always same. And Z01 per unit, we have not proved this. We will take an example little later, then we can prove this. But Z01 per unit equal to what? Z02 per unit. Okay. Simple way to understand is phase current and phase voltage in the primary, phase current and the phase voltage in the secondary relations are what? Same. Similarly, impedance means by default phase only. That's why that is also same. Anyway, we will prove by considering an example. Okay. Now, apart from this, sir, V1L per unit equal to what? V2L per unit, but having some phase angle theta. But this theta is what? Depends on some connection. So that's why better to write this. Irrespective of the connection, magnitude of the line voltage in the primary, magnitude of the line voltage in the secondary are same. Okay. Clear? So this is the conclusions we have drawn from what? Our 3-phase transformer per unit analysis. And second conclusion is, for a transformer, depending on the connection, okay, for a 3-phase transformer, depending on the connection, there exists phase shift between primary line voltage and secondary line voltage. There exists a phase shift between primary line voltage and secondary line voltage. And same thing is true for what? Current also. The third conclusion is what? For a 3-phase transformer, depending on connection, there exists a phase shift between what? Primary line current and secondary line current. Okay? Clear, sir? The third conclusion is, for a 3-phase transformer, same copy paste. For a 3-phase transformer, depending on the connection, there exists phase shift between primary line current and secondary line current. Okay, so for example, sir, if it is a star-star connection, then no phase shift. Careful, sir. Star delta, what is the phase shift? minus 30 degrees. Delta star, what is the phase shift? Plus 30 degrees. Delta delta, what is the phase shift? No phase shift. 0 degrees, better. No phase shift. So these are the fundamental phase shifts. Okay. So that's why whatever the phase shift I written, this is valid for what? Actual values as well as what? Per unit values. Now we will see another example. A delta connected load is supplied from 5 kV 10 kVA supply. The per unit impedance of the load is 0.2 per unit. Calculate the actual impedance of equivalent star connected load. There are two ways to solve this. One is by calculating Z star per unit equal to Z delta per unit. Sorry, by applying Z star per unit equal to Z delta per unit. So we know the Z star per unit, that is also 0.2. Then after that what? Multiply that with what? Z base. Okay, that is one method. Second method is what? Calculate the actual value of Z delta, divide that with 3, so we get what? Z star. Okay, clear? So using star delta transformation, if you know the delta impedance is Z, what is the star impedance? Z by 3. Simple way. So we will go with both the methods. Okay. Now first method is, sir, we know that Z star per unit equal to what? Z delta per unit. Okay, clear? So what I get now? 0.2. Now tell me what is the Z base for star connection, because I know the Z star per unit, because he is asking the actual impedance of equivalent star connected load. So that's why I need to calculate Z base for what connection now? Star connection. What is Z base for star connection? V line base square by what? S base. What is the line voltage base? 5 kV. So I can write what? 5000 square. Okay, 5000 square. Better, because 5000 volts. 10 kVA means what? 10 into 10 power 3 volt amperes. So that you don't have any confusion, sir. Okay, 5000 square 10 into 10 power 3 volt amperes. So if I solve this, what I get here? 2500 ohms. So Z base for star connection is 2500 ohms. Now what is the Z star actual? Z star actual is Z star per unit into Z base, which is calculated for star connection. Now what I get? 0.2 into 2500, okay, which is 500 ohms. 500 ohms is the equivalent star connected actual impedance. So another method is what? Let's calculate Z delta. Per unit value of Z delta is 0.2. Now tell me what is the Z base for what? Delta connection. Z base for delta connection is 3 times VLB square by S base, otherwise 3 times that. So what I get now? 3 into, okay, 2500 ohms, because this value is what? 2500. Just now we calculated. VLB square by S base is 2500. So what is now equivalent Z star? But before that, Z delta actual, Z delta ohms is equal to what now? 0.2 into 3 into 2500 ohms. Okay, but what about Z star ohms? We know that is Z delta by 3. I am talking about actual values. Okay, so Z star actual equal to Z delta actual by 3. Star delta conversion, sir. So what I get now? So if I divide with 3, I get it what? 500 ohms. Check. Both the way we are getting what? Same answer. That means indirectly what my point is, this relation is 100% correct. So again I am saying, so the star connected load impedance in per unit form equal to the equivalent delta connected load impedance in per unit form. That means if we convert star to delta, the per unit impedances will not change. Now coming to this example, the impedance referred to primary of a 10 kV by 100 kV 20 MVA single phase transformer is 25 ohms. Calculate the impedance referred to secondary. And second question, calculate the per unit impedance referred to primary and secondary. If 3 such transformers are connected to form a 3-phase star delta transformer, then calculate its per unit impedance referred to primary and referred to secondary. Okay, clear? So from this we are going to prove the impedance referred to primary and impedance referred to secondary of a three-phase transformer is what? Same. Okay, clear? If three single-phase transformers are converted to form a three-phase transformer, then the per unit impedance will never change. That also we are going to prove from this. Anyway, sir, coming to the first question. So calculate the impedance referred to secondary. First of all, what is the transformation ratio K for a single phase transformer? The transformation ratio K is what? Secondary voltage by primary voltage. So that means 10. So what is the impedance referred to primary? Impedance referred to primary is what? 25 ohms. Now if that is the case, what is the impedance referred to secondary? Z01 into K square. Okay, so Z01 is anyway 10 ohms, sorry, Z01 is 25 and K square means what? 10 square. Okay, so 100, that means 2500 ohms. So Z02 is 2500 ohms, 2500 ohms. Clear? So that is the answer for the first question. Calculate the impedance referred to primary and secondary in per unit form. Tell me, what is the Z1 base? The impedance base in the primary side. So we can write V base square by S base. Otherwise KVB square by MVAB. Okay, KVB square by MVAB. What is the KVB? 10K. That's why directly 10 square. MVAB, so 20 MVA. Okay, so 10 square by 20. That means 100 by 20, which is what? 5 ohms. So tell me, what is Z01 in per unit form? Z01 per unit is what? Z01 actual divided with what? Z1 base. Z01 actual is 25 and Z base is what? 5 ohms. We get what? 5 per unit. Okay, clear? Z01 actual is 25 ohms. Z1 base is 5 ohms. Okay, now tell me, what is Z2 base? Z2 base is V base square, that means 100 square by S base is 20. Okay, so we get here 500 ohms. So if that is the case, what is Z02 per unit? Z02 per unit. So 2500 by 500. So what I get now? Again 5 per unit. So impedance referred to primary, impedance referred to secondary of a single phase transformer is always same. But what about for a three phase transformer? That means indirectly, if three such single phase transformers are converted to form a three phase star delta transformer, then what happens, sir? See, for example, let's say transformer number 1, now transformer number 2, these are the three single phase transformer banks, and transformer number 3. Now these three transformers, what I am doing, I am making a three phase star delta transformer. Okay, three phase na, then let's say this is A phase. Clear? Now what about this? B phase. Clear? And what about this? C phase. Okay, but you must connect the what? The other ends at one point, then only that is called what? Star connection. Now this is the neutral terminal. Okay, but tell me, what is this voltage? 10 kV. As per the rating given, this is the 10 kV rating. If that is the case, what about the line to line voltage? Because default voltage rating in the primary and default voltage rating in the secondary is what? Line voltage rating. Correct or not? It's a 10 kV na? Okay, here also 10 kV, here also 10 kV. Since it is forming a balanced system, that's why this is 10 kV. What about the line voltage? Magnitude only I am writing. Root 3 times what? 10 kV. That means phase voltage base is 10 kV, but the line voltage base is what? Root 3 times the 10 kV. Okay, clear? Now tell me delta side. This side is delta now. Again A phase, B phase and what? C terminal. Okay, but before that, have a look, sir. Delta means what? This is connected here and this is connected here, and what about here? This is how the connection. Have a look, sir. This is the line, this is the line, and this is another line. Okay, line to line voltage means this voltage. Tell me, what is the line to line voltage? Check. Line to line voltage and phase voltage are what? Same. That means what is this voltage? 100 kV. Okay, and what about this voltage also? 100 kV. That means the point is clear here. If you convert a single phase three single phase transformers to a three phase transformer, star connection means the line voltage rating is what? Root 3 times the original voltage in the primary. But delta connection means the line voltage rating is equal to what? The per phase voltage rating of the transformer. Okay, that means the single phase voltage rating of the transformer. That means if single phase transformers are converted to form a star delta three phase transformers, the primary voltage rating is what? Root 3 times what is the original voltage of single phase, that is 10. And what about the secondary voltage rating? 100 kV. Since it is a delta connection here, so I can write what? 100 kV. For example, if it is a delta star transformer, for example, I am just making to form a delta star. In the question he has mentioned what? Star delta. But what I am saying is if it is a delta star transformer, then what you get? This is 10 kV only, because for a delta line voltage equal to what? Phase voltage, because by default it is a phase voltage. And star side means what? Root 3 times what? 100 kV. Suppose if you are converted to form a delta transformer, then the voltage ratings are what? 10 kV by 100 kV. Suppose if you are converted to form a star transformer, then what? 10 root 3 kV, 100 root 3 kV. Clear, sir? So that's how the voltage ratings you need to say. Okay, but anyway, it is what? A star delta transformer now. So that's why. So this is what? The voltage ratings. And what about the power rating, sir? Power rating will be what? 3 times. Because per phase power is x megawatt, means 3 phase power will be 3x. So tell me, what is the MVA rating now? It's not 20 MVA. It is what now? 60 MVA. Okay, clear? Now tell me, what is the impedance referred to primary? Per phase impedance. Whatever the per phase impedance here in single phase, same it is applicable here. Per phase impedance, na? So in case of star connection also, what we talk? We talk about per phase impedance. Impedance is always a per phase quantity. That's why what is Z01 ohms? Z01 ohms is nothing but what? Whatever we given for single phase, same 25 ohms. If that is the case, what is Z02 ohms? Same formula, Z01 ohms into what? K square. Okay, but tell me what is the value of K here? Sir, K means V2 phase by V1 phase. Tell me what is V2 phase? Line voltage and phase voltage are same because delta. So 100. Now tell me, what about V1 phase? V1 phase is root 3 into 10 or 10 only. Sir, this is the line voltage. Correct or not? By default rating is what? Line voltage. Okay. Root 3 into 10 kV is the line voltage rating in the primary. Correct or not? But I want phase voltage. That is what? 10 root 3 by root 3. That means 10 only. So I get 10 only. So that means what about Z02? 25 into 10 square. So which is what? 2500. Just similar to the value what we got. So that means what I can say, if you convert a single phase transformer to a three phase transformer, then actual impedance in the primary of a single phase, actual impedance in the primary of a three phase is remain same. Okay, that's not going to change. Okay, anyway, so the next important thing, sir, we need to calculate, so what is the per unit impedance, right, referred to primary and referred to secondary. Tell me what is the Z base? Z1 base, primary side. Since it is a star connection, what is the formula? VLB square by S base. So what is VLB? 10 into root 3 square. Line voltage in the primary side, 10 into root 3 square divided with what? S base is what? 60. So 10 into root 3 square by 60. So simply speaking, what? 10 square by 20 only. Correct or not? So that's why what I get now here, 500 ohms. Tell me what is Z2 base? 3 into V line base, because why I multiplied with 3 here? Because it is a delta connection on the secondary side. That's why 3 multiplication will come. So what I get now? So 3 times, what is the line voltage base square? So 100 square by what? 60. So again you will get what? So this is, I'm sorry, this is 5 ohms, right? This is 5 ohms. but here we get 500 ohms. So if that is the case, what is Z01 per unit? Z01 per unit, just check what is Z01 per unit. Z01 actual by Z1 base. So 25 by 5 per unit. Now what is Z02 per unit? Directly I am writing, sir, don't confuse. Z02 actual 2500, but Z2 base 500. 2500 by 500, again 5 per unit. So what is the per unit impedance of the transformer here? 5 per unit. What is the per unit impedance of a single phase transformer? 5 per unit. That's why, sir, if a single phase transformer, if 3 single phase transformers are converted to form a 3-phase transformer, the per unit impedance will remain same. Even actual impedance also remain same. With this I am concluding this lecture. In the next lecture we will see how to calculate the new per unit quantities if there is a change in base quantities.